Hi. There's a little sidebar to this talk, which is a couple of years ago, I was going to Strata, which is O'Reilly's big data conference. Alistair's involved in that as well. And he said, what are you going to speak about at Strata this year? And I was like, I don't know, give me a topic. And he said, how about every visualization you've seen is wrong? And I was like, that's a pretty cool topic, I can do that. And I don't want to just do this like part way. Like if I'm going to shoot down other people's hard work, I want to do it rigorously, like with a nice rubric. And so I built this nice rubric for evaluating other people's materials, and realized later on that an even better use of this rubric was to help teach people how to build their own things more effectively. So that's where this came from. Special call out and thanks to Alistair for starting that off. So one more thing here. You'll notice visualization's crossed out. We're going to talk about visualization today. The thing is 80% of the actual process, that's like right up until putting the pixels on the page, we don't have to be talking about visualization. We can be talking about any kind of communication. This can be writing a pitch. This can be building your UI. This can be talking to your parent, your partner, whether romantic, business, or both, talking to your child. All of these techniques for thinking about how to create an effective visualization also apply to other forms of effective communicating with other human beings. So for the first couple of slides here, I've crossed out the word visualization and put the communication in, just to make the point. I'm mostly still going to talk about visualization, but I want you to really remember you can use this approach for other kinds of communication also. All right. Briefly, let's talk, though, about visualization and why we care and why visualization is awesome. This is a sample data set called Anscombe's Quartet. It's a synthetic data set. The interesting thing about this, there's 4 pairs, 4 XY data sets. 3 of the 4 of the X values are the same. In all 4 with the Y values, the sets have the same average, same standard deviation, a few other statistical tests. They look the same. This is a well-known data set. Oops, except, haha, wrong one on the slide. There we go. 4 data sets. Apologies for that. So again, the X's are the same in 3 or 4 cases. The Y's are statistically, if you don't look very closely, are more or less the same. And when you visualize them, you get a really different impression of what's going on there. You see the patterns that are happening here. And it turns out our brains are really good at this, right? This is a thing that you would not get looking at this, understanding what's going on here. You would not get of looking at a spreadsheet. You would not get it looking at a sort of a first pass statistical analysis. So our brains are pattern detecting machines. We're really, really good at this. Sometimes we're too good at this. Sometimes we see patterns that don't actually exist in the world. We have confirmation bias and other reasons for that. But we see patterns, and what that means is we see trends, and then we notice when those trends are broken, when there's a gap or when there's a violation. So if I go back here for a second, we can see the thing that we notice here, there's something that totally violates the pattern, and there's a little gap there, same up in this corner, and in both of these first 2 cases, the overall trend is fairly clear. So if you want to communicate effectively, you can take advantage of the brain's pattern matching and pattern violation finding capabilities. There's also this notion that's come along in the last couple of years that I started seeing conference talks and blog posts and book titles that are all about finding the story in your data or storytelling with data. And I thought that's kind of strange because stories are this sort of interpretive, suggestive, narrative thing, and data is this like rigorous, fact-based, and these are sort of, they're very different. They're sort of very different approaches, this quantitative and this qualitative approach to talking about whatever it is that you're talking about. And I started thinking about why do we have this word stories so often in conjunction with the word data? And it turns out that the stories, they tell you what to pay attention to in the data. They tell you why you care. They tell you what the takeaway is, the message that's in the data is that's interesting. So have any of you seen Hans Rosling, any of his TED Talks, or the Gapminder tool? 1. Wow, all right. Well, you should all go to TED and look too. All right. You should all look at Hans Rosling. He's a professor of public health and a statistician, and he built this tool, which is now sponsored by Google, which is this tool called Gapminder, where you can put enormous amounts of public health data, some of it going back to the early 60s when the UN started tracking this, some of this going back much further. And so what we're looking at here is essentially income here and life expectancy, and we're tracing the different path of these 2 countries. And you can see how these things changed. So there's a ton of data here. There's 200 and something countries. They're encoded with size for population and color for region. We've got 2 quantitative axes. there's a lot going on, and if you give somebody a spreadsheet of this times the 40 or 50 years that we're looking at, if you give somebody a spreadsheet of this, it would be mostly impenetrable. The way Hans Rosling works is he wraps a narrative around it. He tells the story and tells us, look, here's the interesting thing. Life expectancy went way up in Vietnam, and then the economic things improved. Romania had kind of a harder path. Life expectancy didn't go up very much. Income went improved, and then came back again. These are very different narratives. The story, the narrative, tells us why we care about the data. It gives us something to take away from the data. So, on to the 4 pillars. This is how you actually do it. For your visualization or whatever communication you need, this is the way that you can design something that hopefully will be effective. For those of you who are rigorous technical writers in the audience, you'll notice that these are numbered, not bulleted. That means you have to do them in this order. With bullets, it's okay if you shuffle them around, but if they're numbered, this is the preferred order. So, purpose. Why are we doing this? That includes who it's for, what do we hope to get out of it, medium of communication. We'll talk more about each of these bullet points. Content. What's the actual information? What's the data that needs to be communicated? Structure. In this case, structure is what is the graph type? Where do the pixels go on the page? But this can also be if you're anything that's written, anything that's spoken. The structure is the narrative flow. Maybe you write an outline. I highly recommend that. And finally, formatting. Formatting is like typography, branding, color, tooltips, grid lines, labels, all that other stuff. That has to come, but you do that last after you've really nailed the meat of it. By the way, totally invite you to take photos. That's great. My blog, complexdiagrams.com, has versions of this talk, YouTube videos of this, slide decks, white papers, all based on this. I spent about a year working on materials for this at a prior job. So if you're into this, there's a ton of it available on the web. So let's start with number 1. Too many clicks. Number 1, purpose. Start here with your customer. That's my ultimate boss. So ultimately, for the work that I do, that is one version of who my customer is. Understand who it is that is consuming whatever it is that you're creating, whether it's a visualization, whether it's a written document, et cetera. Don't start, in this case, with the graph type picker of some tools. This is particularly bad in a graphing tool because you don't know what the right shape of graph is till you've defined your purpose, until you've picked out the data. So if you start here, it's like you've already sort of built the UI, but you don't know what it's going to do yet. That doesn't really work very well. So it's always about starting with the customer. And you have to ask yourself this sort of questions. Why am I creating this? Who's it for? What do they need to understand? What do I want them to communicate? What actions am I enabling? What questions am I answering for them? One of the tests I use these days is the Jeopardy test. If this UI or this communication or this visualization provides an answer, what is the question that my audience comes with that this answer is going to be satisfying to them? If the answer is, well, we're just going to show them everything, that's really non-specific and not useful. They need to have a particular thing that they're coming for. We'll talk more about that in a minute. The other thing that purpose matters for is this context of use. Visualizations that go in a printed black and white mailed out annual report are probably going to be different than things that are meant to be viewed on a 4-inch screen or a meter screen, right? They're all going to be designed with different levels of detail, different volumes of data, different levels of interactivity, et cetera. So all these things need to be taken into consideration to help define your purpose. Your purpose should be specific. If the purpose is something like show the data, that's not really very effective. That doesn't give you much in the way of guiding you to make good design decisions. It doesn't give you any answers. It doesn't help inform what you're doing. This is a good purpose. This is very specific. It provides some constraints. It talks about who the audience is and what they need to take away from it, right? Revenue and customer base improvements. So we want to be showing the improvement. These are the data sets that we're going to use. Here we have a time frame, last 3 years, and we're showing this to investors so we know that they're going to be making decisions like, is this startup, are they going to be profitable? Is this bit growing fast enough? All these sorts of questions. That's a pretty good purpose. I give talks like this fairly often, and then afterwards people come up to me and say, that was great, I really loved your talk. What graph should I use? I'm like, well, it's not that simple. And I had this conversation like 1,000 times and finally compressed it into one tweet. Take a second there. Everybody, especially engineers, apologies if you're an engineer, everybody wants to start with step 5. Tell me what graph to use. It's like, you can't start with step 5. You have to start with step 1. And then we can work up to step 5. This is my pinned tweet on Twitter if you want to capture this and take it home with you. So people anyway, people start. They want to implement right away, and they don't spend enough time researching. They don't spend enough time asking questions. They don't spend enough time learning about what's going on. And it turns out that this tweet is comprised of we can get to the graph. That's some structure. But really what we'd like to do is we want to move up this ladder. We can give people data, and that's fine. If you refine the data, you can give them information, that's better. You can give them answers, that's even better. I don't want the whole spreadsheet, I just want the answer. And finally, if you can enable people to take an action very easily based on whatever this is, now you're at the top. I guess, there we go, there's the action. Now you're at the top of this sort of information abstraction, right? If you're familiar with the concept of an executive summary, the executive doesn't want the raw data. They don't want to see 50 pages of calculations. They don't want to see necessarily long narrative about it. They want the 2-sentence thing that says we should take this action or we don't. Here's the odds of success, and then they make a decision and then they can move on. So allowing your customers to work with information is great. Bringing it more refined, getting it closer to a recommendation, enabling them the do it now, yes please button. That will serve you very well because it will serve your customers very well. Success generally requires providing answers for people, right? You're helping them actually figure out something in particular. So we want to provide answers. What are we going to show people? We're going to show them revenue. Well, okay, then what? Like that's pretty low level. It's a spreadsheet. No, we're going to give them an answer. Even if it's the same spreadsheet, we can put a different title on it, right? You can have a graph that says fastest growing startups in the Montreal region. That's fine. You can also have a graph that says, startup XYZ was the fastest growing by more than 40% in the Montreal region. Same graph. Haven't changed the graph at all, but you tell people the answer. You tell people the information, the answer that you want them to take away from the conversation. If you have something that you want them to learn in particular, tell them what that is, and your odds of them actually retaining the knowledge that you want them to retain are much, much improved. So in this case, this is just an example answer that could be put on something to communicate a specific answer. All right, so that was purpose. Let's talk about content. What data matters? What relationships matter? This necessarily is informed by your purpose. You can't decide what data matters until you've defined what your purpose is. I spent 16 years of my academic career with people saying, but you have to show your work. And now we talk about big data, and we talk about the velocity of data, and who's got more terabytes. And the problem with that is that most people don't care, and most people don't want everything, right? This is why we have filters. I only want restaurants that are within a mile of me. I only want restaurants that are open now. I only want restaurants that offer vegetarian food, right? Don't show me the whole database. Give me just the answers that I want. So often, less is more. In this case, the bullet, what's excluded, what you refuse to show, is as important as what's included. And what happens is sometimes you get like these dashboards like this that are just miserable, right? And it's like we can convince people that we're smart if we have all the data up there. And that's fine, I guess, but most people don't actually want that. So here's a lovely little example. A friend of mine named Brandon Martin Anderson did the first version of this. He took the United States Census, and there's no map here, by the way. Those of you who think you are looking at a map, there's not a map. There's a bunch of dots, and there's one dot per person from the 2010 United States Census, placed where they were, I don't know what the word is, where the census found them. My friend did this originally in black and white. It kind of blew up on the internet. This was a later iteration done by a university project where they color-coded the dots based on racial categorization in the census. There's also versions of this with Canada and Mexico included. But right now we're going to look just at the US, and this is something over 300 million data points. And you can say, well, we can tell that the eastern half of the country is more heavily populated than the west, and we can see that the predominant mix of colors here in the east is different than the predominant mix of colors in the west. And if you've been to some of these places, you can probably pick out the places you've been to more or less, or if you grew up somewhere or something like that. But we can't have a lot of detailed conversation here. 300 million data points is too many, right? It's too much for most of the useful, interesting conversations we might choose to have. So take a slice of it. This is a piece from Brooklyn. So instead of 300 million data points, this is probably tens, maybe hundreds of thousands of data points. So we're 3 or 4 orders of magnitude smaller here. And now we can have incredible conversations about, what is going on with these streets where there's these very interesting racial divides, and what's up with these little pockets of one racial group in a sort of a larger neighborhood of another one. We can talk about access to public transportation. We can talk about access to banking. We can talk about real estate prices. We can talk about how quickly gentrification is happening in these neighborhoods. This smaller, much more focused view, this reduction of the data that we're talking about, allows us to be much more interesting. We can have much more interesting conversations than we could have when we were overwhelmed with 300 million data points. So all this is to say, this is all under the main heading of content. Please be focused. Understand how much your customer actually cares. Don't tell them too much. My favorite dashboard, which we'll see in a minute here, is a 1-bit dashboard. 1 data point, 1 bit. I wish we'd had one for today before I left the hotel. Do I need an umbrella? I don't want like the 10-day animated false color radar map thing of the clouds. No, just like tell me which jacket to grab because I'm already late to work. Like, this is a great dashboard. This tells me everything I need to know in that moment. It doesn't overwhelm me with too much data. It just lets me have an answer. It's very, very close to saying, this is the action you should take. If I was somebody who used umbrellas, it would be a great way to say, this is the action. Take the umbrella or not. 1 bit. So I think that's a really good dashboard because it's very clear what it does. It's very faithful to its purpose. It's very effective. It does not provide too much content. Now, we've talked about purpose, we've talked about content. I'm going to talk a little bit about some example purposes, and we'll go from there. These are sort of the classics. Comparison. Rank airports by number of weather-delayed departures. So this is just a simple ranking, very clear. Change. Show how rates of malaria over the last 10 show rates of malaria over the last 10 years for these countries. Anytime you're talking about a time span, you're probably looking at how the change, whatever the data metric is, changes over that time. Composition. What is the contribution to the whole? What are the different products that we have, and what is the revenue that we're getting from these different, and how does that contribute to the entirety of the revenue that we're discussing? Correlation. If I change one variable, what happens to the other variables? So these are these sort of comparison, change, composition, correlation. These are sort of the big 4. Most of the things that you're going to do, most of the questions that you're going to ask with your data, most of the answers that you're looking for are going to fall as a category, one of these, or more likely, honestly, some intersection of these. I want to see how my comparison is today, but I also want to see how that's changed over time. So now we've got a combination, for example, the first 2 bullet points. There's also this geographical one. We're not going to talk too much about geography today, but that is a different sort of a purpose. So the reason that we talk about purpose first and then we talk about structure is the structure that you choose is going to convey different types of knowledge more effectively. So these were developed a little over 200 years ago, these 3 types, all by William Playfair. And it turns out that they're very effective at communicating different types of data, different modes of relationship. And they're not arbitrary. This is all based on the science of the cognition, of how we perceive the shapes, of how the eye and the brain work together to extract meaning from what's on the page or what's on the screen. So you can't, you can, people do, but it's not very successful. You can't just arbitrarily pick a graph type for whatever data or whatever purpose you have and assume it's going to work out. If you want to be successful, you pick a graph type that is most effective, that's going to convey the data that you've got most effectively, and there's a reason for this. So, bars are really good for comparison because we are really sensitive to differences in position and length. We can see very, very small differences in the length of these bars fairly effectively. We may not be able to say, is that a 1.5 or a 2% difference, but we can absolutely tell the difference between a 2% and a 5% and a 7% difference. So that's pretty good, and you get much better resolution looking at something like this than you would looking at, for example, a pie graph where you just simply don't get that precision because the eye and the brain are not built for precision in that other mode. But we are really good. We are really good at length, vertical, horizontal position, super good at that. So this is a really good structure if your purpose happens to be one of comparison, because we can see those differences very effectively. This is the same data set, by the way, as the one we just looked at, only now I've connected each color with a line. Lines imply continuity, so these are really good for time. How are things changing over time? Not always, but very often, anytime you want to talk about change over time, line is the highly recommended graph type because our eye and our brain say, oh, that line means continuity. This is how it was. This is where it's moving to. And in this case, you can see we can also do this comparison of values at each timestamp and understand how things have changed if one of these lines has become dominant over time, for example. The classic pies. I did this for a piece of a white paper a couple of years ago, and they didn't touch most of it, but they changed that upper pecan slice to green. And I was like, really? Like, come on. Like, I picked those colors for a reason, and apparently the editors didn't pick up on my very subtle encoding. You'll notice that a lot of the time you find these numbers, the legend next to a pie graph, telling you what the data is. That's because we can't tell, because our brains aren't very good at precision with the pie. There are some people who love to hate on pies. That's fine. They can do what they want. I don't think pies are terrible. You can have successful pies with a couple of guidelines. Number one is you only get to have a few slices that are relevant. You can't have 20 or 30 different slices in a pie that you care about and imagine that you'll be able to compare any of them effectively. You can have 3 that you care about and 20 more that you don't, and that's fine, but you're not going to get precision for any larger number. Well, you're not going to get precision for any of them, but you can roughly see proportion. And in a lot of situations, it's the impression that you want to give, and if you need more detail than that, we go back to text, because text is really precise. So we can get the impression from the visualization and the precision from the text. This is a pro tip that's actually useful. If you arrange your slices clockwise by size, it's very easy to compare, for example, the first and the second largest slice, and you get this lovely ranking in the text around that you need to support the pie, because you don't get precision from the pie. So good structures there. One of my favorites, scatter plot. We saw this before. This is correlation, right? I'm showing how if values on one axis change, I can see a change in the value of the other axis. Scatter plots are really awesome. They have the ability to be very powerful. You can put many encodings, 5, 6, sometimes 7 axes of data can be displayed on a scatter plot. It's easy to make them kind of messy and overwhelming, so you have to be a little bit careful. But if you do need to convey many axes of data, this is a super useful way to do it. OK, so the pro tip, don't do these. I'm just going to do these quickly so they don't burn into your brain. We'll start up here with the radar graphs or the spider plots. These basically draw a shape that is a reflection of the order in which you pick the axes, but doesn't actually have any relationship to data. Don't do that. Oh, don't take pictures. No, this is bad. Don't put this out in the world. I mean, you can. This sort of a radar plot or spiderweb plot is useful if you have cyclical data. If you have data that is seasonal or that changes by the hour of the day. If you have data that's directional. I've seen lovely wind maps done in this way where it's showing the direction of the wind. But in general, you're sort of inventing data that doesn't exist, and that can be very misleading. Pie graphs. Back in election season, this is the 193% pie. That's bigger than any pie in reality can possibly be. Don't do that. That's an abuse of the structure. That's not what they're for. This one, people will always, as soon as you're comparing bars here, people will never know whether you're meant to be looking at the total length of the bar or the fraction around the clock. And even if you design it one way, there's going to be some fraction of your audience that interprets it the other way. It is, by definition, always going to be wrong for some people. So please don't use it, even though circles are cool and we all love them. And finally, 3D anything, by definition, 3D has to distort your data. It also often obfuscates your data. You can see that you can't see the data back there. But really, you can't actually get any quantities off of these. They're floating some distance from the scale. It's hard to tell what it is. Like, you can't actually get data off this graph. That, by definition, is a failure of the graph. Don't do those. All right. We've talked about purpose. We've talked about selecting the right content. We've talked a little bit about picking an appropriate structure. Formatting. If you've ever made a homemade cake, a really fabulous, delicious homemade cake, and then maybe you let your 5-year-old frost it, and it kind of looks like something a 5-year-old did. It may not be too pretty, but it's a really great homemade cake, and everybody enjoys it, and it totally fulfills the purpose of a cake. Awesome. That's a good cake. The flip side is this. You realize it's somebody's 10-year anniversary at work. You want to throw a party for them. You realize this about 3 o'clock in the afternoon. Somebody runs out and gets a cake from the grocery store. It's really pretty. It's a terrible cake, right? Good frosting will not save a bad cake. You got to have a good cake. You got to have a good foundation. You can format things and make them super pretty and beautiful, and if the purpose is not well defined, if the wrong data is there, if it's the wrong structure, the pretty formatting is not going to save it. I've seen wonderful, amazing, insightful graphs that are these grainy, like 48 DPI, looked like they were mimeographed. Do you guys know what mimeographs are? Looked like they were mimeographed, like really amazing, insightful, even though they weren't pretty. And I've seen all kinds of super, super pretty things that were basically worthless because no thought had actually gone into what is the purpose, what is the structure, et cetera. The job of formatting is to make consumption easier, more appealing, to call attention to what matters, to make the whole experience better for the people who are consuming it. So here's a super, super quick example. It took me about 5 minutes to make this. This is just a tiny little data set. I threw this into Excel. I turned on all the badness in Excel, and it's just like a sort of a little micro nightmare of the worst of what graphs can be, right? The typography is weird. They've got the 3D going on. You can't actually tell where those lines, or those ribbons, I guess, maybe intersect the grid. We've got some color in the background that's, I don't know what it's doing there. You can do good stuff in Excel. You just have to be really careful. All the defaults in Excel are wrong, by the way. When you turn off all the defaults and make good choices, you can do great stuff in Excel. So, this was we will call this bad and distracting. You can almost, everything on the page is removing my attention from the actual data. I took about 4 seconds and dumped that into an Excel template. This is not perfect. I should have fixed the dates and done some other things. Still in Excel, but now I can actually learn quite a bit from the data fairly easily, fairly simply. This is only a change in formatting, right? I haven't changed my data, haven't changed my purpose, haven't changed my structure, except to eliminate the 3D. This one, if you need to actually get data off the screen, much, much clearer. The template I used is written by a woman named Cole Nussbaumer, who realized every time she sat down at Excel, she changed a bunch of things. She turned off all the defaults. She made her own choices. And she's like, I should just templatize this so it's the right way every time. So she's made this publicly available. It's called Unbroken Excel, I think. There's a link to this also from my blog, which is easy to find. Here's a much more advanced formatting option. Usually we show the US map, but this is from UK elections a couple of cycles ago. And this is the geography here in the lower corner. So this is, geography is really good if you're navigating and if you're selling real estate, and it's almost worthless for anything that has to do with population. Because representative populations, the distribution is really uneven. For example, this little tiny bit here that's London becomes this really massive section here. The entire bit of north here that is Scotland is, you know, just a few little hexagons up there. So what they've done with the formatting is they've changed this so that you can actually understand what happened in a more a way that is more accurate and more true to the data. Not to the geography, because no one's navigating using this map. No one's selling real estate based on this map. We care about what the election results were. So they've color-coded which party came ahead in each district. They've used saturation to show by how much that party led in the district. And they've given each district one hexagon here so that all districts are represented equally. So quite a lot of formatting was involved here to get this to the point where they wanted it. But what they've done is they've really transformed you know, a not bad, but really not very quantitatively consumable map into one that's pretty effectively done. So that's pretty fancy. Most people are not going to work at that level. All the stuff I just talked about with formatting and making good choices, to a degree, is in this chart. This is on my blog, complexdiagrams.com. You can download a PDF or a PNG, or I don't know what format, of this chart and hang it up. This is essentially a method of taking a data type, quantitative data, categorical, ordinal, relational, and understanding what are the useful visual encodings. I could talk about this for an hour. I have. It's on YouTube, also linked from the blog post. And there's also a white paper that you can download. It's like 8 or 10 pages. It's mostly pictures. It talks about how to use this. But essentially, this is a cheat sheet. This is a shortcut guide for I have these different types of data. What's the right way to put them on the page visually? I'm not the first person to make a chart like this, by the way. This just happens to be the one that I drew. So the summary. If you're going to be effective in your visualization or any kind of communication, you have to have a clear purpose. Understanding who is your audience and why are you communicating with them and what is the outcome that you hope to have, what's the decision you want to make, you want them to make, what's the action you hope that they will take in response to whatever it is you put in front of them. Maybe you're just educating them, but often we want to convince people of a thing, like invest in my company or buy my product or whatever it is, go on a date with me, whatever the thing is you want to convince somebody of, understand what your purpose is as you're crafting the communication. Once you understand your purpose, you can then focus the content down to just what's necessary. Don't give people too much background. They can always ask for more. Put it in the appendix, but really get the message out there concisely. You'll lose fewer people as they drift away because you're boring them with too much detail. Select a structure. Got to have the right structure that reveals the most important data and relationships. That's it. That's the goal of the structure. That's the whole point of putting the pixels on the page. Reveal what's most important, whether it's the data or the relationships. You got to have that. After you've nailed all that, you can then use formatting to focus people's attentions, not to distract them, but to bring their attention into the points that matter the most, that you want them to interact with. These are not on SlideShare, but I'm going to put my talk from this morning on SlideShare because people keep asking. I'll put this version of this up as well, and I'll tweet links. That way you don't have to retype these. You can just click on them and they'll all be embedded. But Twitter's the best way to get in touch with me if you're interested in that sort of thing. Links to the various blog posts I keep talking about. Before I wrote this talk a couple of years ago, I had another fairly long talk about data visualization. I spoke at LinkedIn at one point, and they said, and talk about social networks, and we want you to talk for 2 hours. So there's an almost 2-hour video of me on YouTube that for some reason has like 50,000 views, and I don't know who's spending 2 hours watching me on YouTube, but people seem to be doing that. And it's related content, but it's not the same talk, and people seem to like that. And then I gave a very short talk on maps, my favorite talk that I've given, the Excel template. There's one more thing on here, quick site. You just heard quite a lot, if you were in this tent before, about AWS. I went to work for AWS 2 years ago to help build a product called QuickSight, which is our cloud scale business intelligence and data visualization tool. I did a lot of different things with that, but I was also responsible for the part of the tool that picks which graph to put on the screen when you say, I have these kinds of data, what should I do with it? So I think it's a great tool. It's in private beta, so you have to apply to play with it these days, but it should be out in the world soon, so I'm pretty excited about it. That's the talk. And I think we're supposed to have time for Q&A, and I don't know if that'll be moderated or if it's just me. There he is. Sorry, I finished 2 minutes early.
Yo, no, you killed it. I think we should take a couple questions. What do you think?
Yeah, that's good.
Sorry, I was preoccupied.
You were busy.
Yeah, no, I'm good. I'm good. So we have a chance for 2 questions. Anyone interested? If not, there's a... Oh, hold on. Yeah, we got some. I'm on my way. Hold on. Because you're on the other side, it might actually just be 1 question. Hang on 1 sec. We got this. Boom.
Thank you, sir. I design data visualizations. I am an academic. I've worked in industry, Google, various places. At Amazon right now, are there actually data visualization roles, like specific roles, or is it just like part and parcel of a regular kind of SWE role?
It is effectively a part of an SWE role, but not intentionally. Right now, I work for the general UX group for AWS, and I do a lot of sort of micro consulting for different teams as they build dashboards, either internally or for customers, or as they put together visualizations. So there are not, today, you can't just go search for visualization. You might get someone who's intended to build the front end, but there's not designer roles for that. Maybe if we're lucky, that'll change. They kind of got me in the UX group as a fluke after I finished my work on the other team. So. But there's obviously demand. We have a lot of data that we like to represent usefully.
No, if people want to ask you more questions, how can they get in touch with you?
Twitter's a great way to find me. I'm fairly accessible on Twitter. I have fairly visible clothing, which is now
designed.
Dried out from lunch, finally. And this has got reflective stripes in the plaid, so if you go around with a flashlight at night, I'll light right up.
This guy is not joking. All right, guys, a big round of applause.
Thank you.